hope you're doing good today or tonight, whatever time of the day or night it is for you. Today we're going to talk about parallelograms in the coordinate grid, and you will feel like you have already seen this lesson because we have seen versions of this lesson when we studied triangles, and it just reinforces a bunch of skills that you're going to need in Algebra 2 and pre-calculus and for the ACT. So let's get started. All right, today you'll be able to apply the properties of parallelograms to verify a quadrilateral in a coordinate plane is actually a parallelogram. So today it's not about, it's really about verifying. So I hate to say the word proof because you're not proving, but you're going to have to show your work. That's the whole point of this lesson, is I need to be able to read what you wrote so I know that you understand what makes a quadrilateral a parallelogram. So let's just do a quick review. What actually makes a quadrilateral, a parallelogram? You do not need to write this down. You wrote it in yesterday's notes. So just follow along with me for a second and listen to my fast talking. All right, a parallelogram is a parallelogram if both pairs of opposite sides are parallel. So both pairs of sides are parallel, you have a parallelogram. If opposite angles are congruent, you have a parallelogram, and that is both pairs of opposite angles. If all consecutive angles are supplementary, you have a parallelogram. If both pairs of opposite sides are congruent, you have a parallelogram. And then if one pair of opposite sides have both parallel properties and congruent properties. So one pair of opposite sides is parallel and congruent, then you have a parallelogram. And last but not least, the diagonals bisect each other. So when we look at these properties of parallelogram, we need to think about which of these can be modeled on a coordinate grid. So when we look at plotting points and making a quadrilateral on a coordinate grid, I can do a lot of things with the sides, but I can't do much with angles. So if I really kind of think about this, I can show on a coordinate grid by using slope that both pairs of opposite sides are parallel. However, I cannot tell you by doing anything on my coordinate grid that opposite angles are congruent. I cannot tell you that consecutive angles are supplementary. I don't really have a way to measure angles on a coordinate grid unless I literally get out a protractor and try to do it that way. Could I show that both pairs of opposite sides are congruent? Well, we have the distance formula, and so I could use the distance formula or the Pythagorean theorem to show that those opposite sides find the length and verify they're congruent. And I could definitely show that one pair of sides is congruent and parallel. And I can also show that diagonals bisect each other. So how can I do this? So how would we show that two lines are parallel on a coordinate grid? Well, if I'm on a coordinate grid, I can find the slope. And if the slope is the same, I know that the lines are parallel. How could I show that two lines have the same length? Two line segments have the same length. Well, I could use the Pythagorean theorem, which is actually a form of the distance formula, and I could find the length, and I could compare sides. And then how can I show that two segments bisect each other? Well, technically what I could do is I could find the midpoint twice. So I would have to find the midpoint of each segment, each diagonal, and then I would have to show that those 2 points are the same. So this is example 4 from your notes for 7.3. It was the example that we didn't do. So I want you just to take a minute, hit pause, and I want you to plot the points on your coordinate grid. It will be extra helpful if you will actually label them with the letter and the point X and Y value so that we can use those for our problems. Once you have it, the quadrilateral plotted, then hit resume and we will continue on. All right, welcome back. So we want to verify that this shape is a quadrilateral, so I could do lots of different things. I think what I'm going to do is I'm going to find the slope of the left side and the slope of the right side, and I want to show that those two slopes are the same. So if I find the slope of kj, I'm going to take y minus y, so 7 minus 3 all over x minus x, negative 5 minus a negative 2. So my slope is 4 over negative 5 plus 2 is 4 over negative 3. And that's the slope of kj. If I come find the slope of lm, I'm going to do the same thing, y minus y over x minus x, which would be 3 minus 6. That's going to give me 4 over negative 3. So because those two line segments have the same slope, then I know for a fact they parallel. They are parallel. So now I have to think. I can do a couple different things. I can show that kj and lm have the same length, or I could show that kl and jm have the same, or that are also parallel. But I think what I'm going to do is I'm going to find the length of kj, just so we can do the distance formula. So a couple things could happen here. You could use coordinates and do distance. So this is going to be x minus x, so negative 5 plus 2 squared, and then y minus y. So if you continue on with the Pythagorean theorem, this becomes negative 3 squared. If you are using your calculator, watch that negative. If you don't have that negative 3 in parentheses and you use your calculator, then you will get the wrong answer. You can leave your answers as a radical, or you can simplify them. So I get that the length of kj is 5. You could have also come in on your picture, because these pictures are actually pretty good. You could have counted that this was 4. You could have counted that this was 3. And you could have done the hypotenuse squared equals leg squared plus leg squared and done the Pythagorean theorem. You would have gotten the same answer. Now that I have the length of kj, I also need to find the length of lm. So to do the length of lm, I'm going to do the distance formula again. So x minus x, skipping a step and doing some math in my head here, is negative 3. And y minus y, 6 minus 2 is 4. And I can tell right now, if I match the numbers here up with the numbers here, they're the same. So this is going to be 9 plus 16, which is the square root of 25, which is 5. So I have one pair of sides that is congruent and parallel. Therefore, this shape is definitely a parallelogram. And that's basically what you're going to do on tonight's assignment. They tell you exactly what they want you to do. So some of them, they ask you to prove that both sides are parallel, both pairs of sides are parallel. And if that's the case, then I absolutely, positively, you're going to have to come in and you're going to have to show me the slope formula 4 times. Or if they say show that both pairs of parallel, or the opposite sides are congruent, you're going to have to use a distance formula 4 times, and I need to see the entire distance formula. So, all right, well, short video today. Hope you have a good rest of your evening or night, and I will see you guys tomorrow in class. Bye-bye.